Hi everyone, welcome back to my channel. This is Mr. Budehas, your online math teacher. In today's video, you will learn the angle of depression. At the end of this lesson, you will be able to accurately define and give examples about angle of depression and accurately solve problems involving angle of depression using trigonometric ratios. In my previous videos, I discussed already the 6 trigonometric ratios and the angle of elevation. Just check for the link in the description. Let's start. Let's learn first what is an angle of depression. The angle of depression, it is the angle between the horizontal axis and the line of sight to the object when the observer looks downward. For example, I have here an illustration. The observer is inside the treehouse and the object is the dog. The observer looks downward and we have here, this line is what we call the line of sight, and this is the horizontal axis or the horizontal line. Now it forms an angle here which is what we call the angle of depression. Let's try some examples. Number 1. The angle of depression from a lamppost to a point on the ground is 60 degrees. How long is the light beam to the nearest whole number if the lamppost is 10 meters high? To solve this, we need to illustrate first the problem. We have here the lamppost and the angle of depression as given, which is 60 degrees. And this line of sight here is what we called the light beam. And we are looking for how long is the light beam. So we let it be x as the length of the light beam. This problem can be solved in two ways. First, this is the first way. The right triangle can be measured or can be constructed as shown. This is the right triangle that is coming from the light beam and the lamppost. The lamppost is 10 meters. This is the side here. This is the lamppost. And this 30 degrees is coming from here. The given angle of depression is 60 degrees. Now take note that the lamppost and the horizontal line here is a right angle. So we need to find what is the measurement of this angle here. So 60 plus x is equal to 90. Our x here is 30. That is why we have here 30 degrees. That is the complementary angle of 60 degrees. And this is the light beam. We let it be x. Now we are going to identify what trigonometric ratios are we going to use to solve this problem. Since the involved sides are, this is our viewpoint here or the angle of focus, this side here is the adjacent side and we have here the longest side is the hypotenuse. So we have adjacent side and the hypotenuse, which is the cosine. So we are looking for the measurement of the light beam. So we are going to use the cosine theta or the cosine ratio. Cosine ratio involves adjacent sides and the hypotenuse. Our angle theta is equal to 30 degrees. So we have here cosine 30 degrees is equal to adjacent side is 10 meters and our hypotenuse is x. So 10 over x. We are going to multiply both sides by x. So now we have x cosine 30 degrees is equal to 10. Then divide both sides by cosine 30. So we have x is equal to 10 over cosine 30 degrees. And 10 divided by cosine 30 degrees is approximately 11.547. Therefore, the length of the beam of the lamppost is approximately 12 meters. The second way, or another way of solving this problem, is by recalling the properties of transversals to parallel lines. Let us illustrate the problem with a different triangle. This is our first way in which we use this angle here, which is 30 degrees. Now we will be using another angle of focus, which is this one here. And where did we get that 60 degrees? Take note, please do remember or recall for the properties of transversals to parallel lines. Notice that the upper and the lower horizontal lines are parallel, cut by this transversal line x, making the angle of depression and the angle of elevation congruent since they are now the alternate interior angles for the parallel lines cut by a transversal. So the angle of depression here is equal to the angle of elevation. This is now the angle of elevation. So we will be using the angle of elevation. In this case, we will use the sine ratio since we are dealing with the opposite and the hypotenuse. Since this is now our focus, the 60 degrees, and the 10 meters or the height of the lamppost is now the opposite side, and still we have the hypotenuse. So we have sine theta is equal to opposite over hypotenuse. Our theta measures 60 degrees. So we have sine 60 degrees is equal to 10 over x. 10 is the opposite and x is the hypotenuse. Then multiply both sides by x. So now we have x sine 60 degrees is equal to 10. Next, divide both sides by sine 60 degrees. So we have x is equal to 10 divided by sine 60 degrees. And 10 divided by sine 60 degrees is approximately 11.547. Therefore, whichever angle is used, the answer remains 12 meters. That is approximately 12 meters. Example number 2. Anthony is standing on top of a hill and spots a house in the adjacent valley at an angle of depression of 12 degrees. The base of the hill to Anthony's line of sight is 60 meters high. How far is the house from the base of the hill? First, we are going to illustrate the problem and let x be the distance of the house from the base of the hill. This is the base of the hill and this is the house. So we are looking for the distance and that is our x here. Take note that there are two ways in solving this problem, but for now, I will be using the angle of elevation to solve this, using the idea of the transversals of the parallel lines. Relative to the 12 degrees angle, the opposite side is just as long as the height of the base of the hill to Anthony's eye. This is now our angle of focus, because we will be using the opposite or the alternate interior angle of this angle of depression, which is this angle of elevation here. So they are just congruent, therefore this is also 12 degrees. Since this is now our focus angle here, this side must be the opposite side. So the opposite side is just as long as the height from the base of the hill to the eyes of Anthony. The distance from the house to the base is equal to the length of the side adjacent to the 12 degrees angle. So this is now the adjacent side. Therefore, the trigonometric ratio that we are going to use is the tangent ratio, since it involves adjacent and the opposite side. So that's the tuwa in Asoka tuwa. So tangent is equal to opposite over adjacent. So this is the formula for the tangent ratio. The opposite side measures 60 meters. We have here 60, and the adjacent side is x. So we have here 60 over x. Now multiplying both sides by x, so we have x tangent 12 degrees is equal to 60. And then divide both sides by tangent 12. So we have here is x, and for this side is 60 divided by tangent 12 degrees. And 60 divided by tangent 12 degrees is approximately 282.277. Therefore, the house is 282 meters away from the base of the hill. That's all for today. Now I want you to answer these two problems under individual practice. And please do comment your answers below so that I can check if your answers are correct. And that's all for today. Thank you for watching.